We are going to look at nonlinear inequalities. You know how to work linear inequalities. We're going to look at nonlinear inequalities. And we will look first at quadratic, and then we'll look at a couple of rational. And this will be on your test Friday.
Ahmed.
All right.
What number are you? Why do you keep...
Here we have a quadratic inequality.
Okay.
And we already looked at this on your warm-up. You told me that the zeros, if this was an equation, what did you tell me the zeros are going to be?
It would be negative 3 and 1.
Well, we know it's going to do this, right?
And then it would be...
Okay, so if we get a negative number, that means that one of those has to be negative. But what we first want to do is identify the zeros, which are 3 and negative 1. And we're just going to draw a little number line and do some test intervals. So what I want to do is choose a value in each of those test intervals to see if I get a positive answer or a negative answer. All right? Because we're looking for what will make this inequality negative. So if I choose, let's say we look at x is negative 2. If I plug a negative 2 into the factored form right here, because that's usually going to be easier to plug in, I don't care what it is. I just want to know, is it negative or positive? I really don't care what the number is. So if we plug in a negative 2, we're going to get a negative 5 times a negative 1. Is that going to be positive or negative? Positive.
Wait, what?
It's going to be positive.
That was positive 5.
Okay, so let's choose something in the next interval. Zero's easy. I always like to do 0 if I can do 0. We could have done 2, but 0's easy. All right, so I'm going to choose something. I'm going to look at 0. We'll have negative 3 times 1. Does that give me a negative or a positive? A negative. Okay, now let's look at something in the next interval, greater than 3. So if we do a 4, we're going to have 4 minus 3, which is positive, and 4 plus 1 is positive, so a positive times a positive is? Positive. So what interval gives me negative values, values less than 0? Between here and here. So the solution set is negative 1 to 3.
Wait, the what?
The solution set. See, it's not just one answer. It's an interval from negative 1 to 3 would make that a true statement. Anything I plug in between negative 1 and 3 gives me a value that's less than 0. If we were going to look at the graph, we know this is quadratic. We set our zeros at negative 1 and 3. That means that's where it's going to cross the x-axis. So it's really going to look something like this if we were to graph it. Notice the values between negative 1 and 3 are less than 0. So let's look at another one.
Wait, what?
Looked at 4x squared minus 5x minus 6. So let's go ahead, since we've already got that factored. And we want to know, this time, let's see, where is this greater than 0? Actually, I'll say greater than or equal to. So how did we factor that one?
Negative.
It's over on the side.
Negative x minus 8, x plus 3.
Is that how we factored it, Dimitri? How did we factor it?
X minus 2 for x plus 3, so the x's cannot be 2 or negative 3 over 4.
Okay, well, in this case they can, because it's not rational. But that's the zeros.
Okay.
So x is either 2 or x is negative 3/4. Did you have a question, or were you going to answer that?
Yes, I have
Okay.
a question. Just a real quick question. Is 0 a positive number?
0 is considered neither negative or positive.
Okay.
Robert, wake up.
Ahmed. Jeez.
Okay, so we're going to do the same thing. I've got a 0 at x is negative 3/4 and a 0 at x is 2. So I'm going to just test the intervals. I'm going to choose something less than negative 3/4. So we could do negative 1. So if we plug in a -1, we have -1 minus 2, which is a negative. And -4 plus 3 is negative, so negative times a negative is positive. So in that interval, it's going to be positive. If I use a 0, if I plug in 0, am I going to get a negative or a positive?
Yes.
One or the other. Which?
A negative.
Addie says positive, Maddie says negative. Where do you weigh in, Sean?
It's -2 times, hey, I'm good. It's -6.
So it's negative. And if I choose a 3, am I going to get a negative or a positive? Positive. Okay, it may not always come out negative, positive, negative, positive. Sometimes you could get a negative, negative, positive. So we need to check our intervals. Now, we're looking for where this is greater than or equal to. So we're going to include, if we were going to do it on a number line, it would look like this. But if we list our intervals, we're going from -infinity to -3/4, inclusive, and from 2 to infinity. One that is not quadratic, but it's still nonlinear. 2x cubed minus 3x squared minus 32x is greater than -48. What do I need to do first, Sean?
You factor the left side? Or,
Can we do that yet?
oh, no,
I have to move the 48 over. Thank you, Maddie. Okay, so we want to know where are we going to get values greater than 0. This is like the factor in just a minute ago, Will. I'm going to look at those two and look at these two. Is there anything common in the first two that I can factor out?
Eight.
X squared.
Oh gosh, I was looking at that.
And I'm left with 2x minus 3. Can I factor anything out of the next two terms?
-8.
-8?
It doesn't.
Anything else?
No.
How about a -16?
That'll work too.
Because 16 goes into 32 twice,
Alright.
and 16 goes into 48 3 times.
Right.
See, I want to make sure that these two match.
Oh, and then you still have to factor the other one.
So we still have to factor the other one. How does it factor?
X plus 4, x minus 4.
X plus 4 and x minus 4. So that's going to give us an extra interval to check.
Dang it, I always broke. Oh.
All right, so let's do our number line. What are our zeros here?
4, -4,
We have -4, we have 4, and we have
3 halves.
3 halves. So if I choose something less than -4, say -5, I'm going to get a negative times a negative times a negative.
That's going to be a negative.
So this interval's negative.
So do we plug that value back into the original one?
Well, I'm plugging it into this factor form. I don't really care what the value is. I just want to know is it positive or negative. So it's pretty easy here because -10 minus 3 is negative. -5 plus 4 is negative. -5 minus 4 is negative. So negative, negative, negative is negative. Yes.
so when you have more than one, like a zero like that, you're just trying to just find,
We check each interval.
like numbers in between the two.
Yes,
intervals.
yes. So between -4 and 3 halves, probably 0 is the easiest to check. So we're going to have a negative times a positive times a negative, which is
Negative times positive.
positive. Okay, and let's check 3. If we plug in a 3, I'm going to have 6 minus 3, positive, positive,
Positive. So
Neg-
it's positive.
3 minus 4.
Oh gosh, I thought you said 6. But it's negative.
Okay, and then if I choose something larger than 4, what's going to happen?
It's going to be 0. Yeah, it'll be 0.
Larger than 4?
No, if you pick 4.
If I pick 4, that's why I have to pick something larger than 4.
I see. Then it'll
So
be positive.
it'll be positive. So this is another one of those instances where it does rotate, but they don't always. So we want to know, where are we greater than 0? This time we didn't have an equal to, so it's here to here and here. So if we want to list that out, you don't get it?
Oh, no, I get it.
No, she's talking about some boy.
And 4 to infinity.
That's enough.
X squared minus 4x plus 4 is greater than 0. How does this factor?
X minus 2, x minus 2
So that's really x minus 2
squared.
squared is greater than 0. Is it ever not greater? Will anything ever make that not greater than 0?
No.
Well, no.
Okay, what happens if x is 2?
Then it's equal to 0.
It equals 0. Do I want to know where it's equal to 0?
No.
No, so it's everything except 0. This is everything except 0, so we could go from negative infinity to 2 and 2 to infinity. We have to exclude 2 because I didn't ask where's it equal to 0, just where's it greater than 0. Okay, so sometimes you may have to consider in behavior. If you can't factor something, you might have to use the quadratic formula to factor it. What happens if we get a negative under the radical?
Burn it.
If we get an imaginary, so that means it's an imaginary root, so it's not going to touch the x-axis, right? So depending on whether you have in behavior like this or in behavior like this, you have to compare that to see whether or not it would fit in your answer. Example, x squared plus 3x plus 5. I want to know, where is that less than 0? What's the in behavior?
Falls, rises right.
Like that?
Rises up, yeah.
We know a parabola goes like this. All right, we can't factor this, so we know the quadratic formula is x. I really only need to worry about what's underneath the radical for right now. B squared minus 4ac. Is that going to give me a positive number?
Well, dang it, I messed up.
9 minus 20. This is going to be imaginary, right? Means it's not going to touch the x-axis. And if it's up, can it ever be less than 0?
No.
No. So this is a no solution. Because this is an imaginary root. We know the in behavior is rising to the right and the left, so it can't ever be less than 0. The vertex has to be above the x-axis. Let's look at a rational function. Do it the same way. Look at this one. We're going to have to subtract that 1 before we start because we want to compare it to 0.
So do we always want to compare it to 0 every
Yes, yes.
time? Okay.
Now, when we have fractions, we have to get a common denominator. And you can use the famous butterfly method if you want to, which is going to be 3x minus 5 minus x minus 3 over x minus 3. And we can simplify the numerator. And it becomes 3x minus x is 2x. And negative 5 plus 3 is... Robert, wake up.
Ahmed.
Do you get? No.
All right. Now we can do our number line. What makes the numerator 0?
One.
1. What makes the denominator 0? 3. Can we include the denominator value? So I'm going to just put a circle to remind me I can't include that, even though it's asking me for less than or equal to. So now we just check intervals. If I choose 0, what do I get?
Negative. No.
Positive. Now, had this been a plus 3, it would be negative. If I choose 2, what do I get?
Negative. Negative.
Because you get.
Okay, and if I choose 4? Positive. Usually they will rotate like this, but you can't, they don't every time, so you need to check your intervals. So where is the solution to this?
Negative infinity to 1. See, this is the part I don't get.
What is it asking me? What is this? What does this mean right here?
Less.
It's less than or equal to
If it's less than or equal to 0, is it negative or positive?
Negative.
It's negative. So which is the solution?
Negative infinity to 1. All right, no. Hold
It
up.
would be 1.
1 to 3.
1 to 3.
It's 1 to 3.
But you have a bracket on the 1 and a parentheses.
Yeah, so if we're going to list it in interval notation, it's 1 to 3.
And you put the 3 in parentheses because you can't include it because of the denominator.
Correct.
Right? Okay.
Exactly. Exactly.
Oh, this is easy.
That's it. So not a bad section. So your assignment is on page 201. And it's 13 to 23 odd. And 31, 33, 41, and 43. So we will have class again on Thursday, and we'll do a review, and you have a test on Friday.